Going through question 4. Let's see how it goes. Here's our question 4. 4a says, explain why. So the whole of question 4, just from what I'm saying, is it's going to be based on the intermediate value theorem. And it's just, intermediate just means in the middle, okay? So it's a theorem which just tells you that there's one thing which everybody should know in here, is that when we have an equation, whatever the equation was saying, if we have an equation and we get a solution, it's like when we make an equation equal to 0, like here, in here, where we have cos x minus x. If we say cos x minus x is equal to 0, if we find solutions for x, like to say x is equal to blah, 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 and x is equal to whatever, even if it's 1 or there are 2 solutions, what a solution is just, it's either called a solution or a root. What a solution or a root is just a point where it's like an x value, and it is a point where your f of x or your y is equal to 0. It's a point where your graph cuts the x-axis. That's a solution. So if we have a point where our graph cuts the x-axis, this would have been a solution. So when we say we want to find if something is a solution or a root or whatever, we're just trying to say, is there a place where that equation cuts the x-axis? Is there a point where it cuts the x-axis? That is what we'll be proving. Now, the easiest way to know is we can try to choose 2 values, which will be a and b, okay? And if we find 2 values, we want to find this a and b will be 2 values that are special, in that a will be a value which like gives you a solution which is positive. So this will be f of a. F of a, remember, is the solution when you put a in the equation. Then b will be a point which gives you a solution which is like negative, okay? F of b. Or the vice versa can be true, to say that a can be the one that gives you negative, like we can have another, where a is the one that's giving you something negative, and that is your a point. Then you have another point b, which now gives you something positive, okay? They can be both x and a and b can be both negative points, we don't care. But what happens is, if a is giving you, if a is a point on your curve or function, and it's giving you a negative answer, and b is giving you a positive, this just means that somewhere between a and b, there is a value which we'll call c, which gives us 0. Okay, so we'll be saying f of c will be equal to 0. It gives us 0, and that means c is a root, a solution, because we are looking for solutions. So what we are calling c is a root or a solution, which is a special value, a value that gives us an answer of 0. I mean, if you have a curve and one part is negative, the other part is positive, that means somewhere in between those 2 parts, it passed through 0, because how do you come from negative to positive without passing through 0? You have to cross through 0. So that's just what it means. Like here, it was positive. We know that somewhere it passed through 0 for it to come from positive to go to negative. Even if it does this and then down and then, and then does this, we know that somewhere it passed through 0, okay? It may have passed through 0 twice. So we are looking for the points where it passes through 0. So in other words, what we'll just do is, we'll find one point which gives us a negative solution and one point which gives us a positive solution. Then we will know that in between those 2 points, there's a point which gave us a 0. Okay? We are not finding that point. We are just proving that it's there. And how are we proving? By proving that one value gives us negative, another gives us positive. And we know if one value gives us an answer which is negative and the other gives us an answer which is positive, in between those 2, there has to be a point which gives us 0. That is if the graph is continuous. Okay, if the graph is continuous between a and b, a graph which doesn't jump. If we know that the graph is continuous between a and b, and a gives us positive, and b gives us negative, there is no jump, there is nothing. A gives us positive, then we know that there has to be a c which is between them, which gives us 0 as our answer, okay? So f of c will be 0, which is the solution. So this is what we are just proving. You can find more values where I explain this even better. But here I'm just explaining it for us to be able to answer this question. So now let's answer this. What is question 4 wanting? Let's answer the part A. They are saying now, they're saying, explain why has at least equation cos x equal to x has at least one solution. So explain why that equation has at least one solution. So it's your job to find 2 points where one gives an answer which is negative, the other one gives an answer which is positive. And we'll be knowing that between those two, there is a solution. The solution is there, okay? As long as what? Because this is a continuous, cos x minus x is just a continuous thing, okay? We know that the ones that may not be continuous have fractions and whatever. Now let's put this. So we can say cos x is equal to x, which means that cos x minus x is equal to 0. Now, once we have something being equal to 0, we now come and introduce an f of x to say, let f of x be equal to cos x minus x, this thing which was equal to 0. We let it be equal to f of x. Now, what you're going to do is pick 2 points. And these points are usually 0 and 1, they work, or 1 and 2, okay? So we can say, let x be equal to 0. What would we get? F of 0 is equal to cos of 0 minus 0. Which is equal to, wherever this is cos x minus x. Wherever there's x, we are now putting 0, okay? This is going to be cos of 0 is 1 minus 0, which is equal to 1. Now, let's try 1. We say now, let x be equal, you first try with a pencil, okay? F of 1 is now going to be equal to cos 1 minus 1. You get it? Now, what is cos of 1? Cos of 1 is equal to 0.540 blah, 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 minus 1. Which gives us a negative, okay? Which gives us a negative 0.4596 or 97. We don't really care about solutions, okay? We've just proved that one is positive, the other one is giving us a negative answer. So that means definitely between 0 and 1, between x0 and x1, there has to be a solution there. So we've proved that there is a solution. What is the solution? A point which will give us exactly 0 as our answer when we put it. It's an x value which will give us exactly 0 as our answer. One is giving us positive, the other one negative. So it means in between them there is a 0. So you can now say here, since f of negative, we start with the one that gives us negative. So since f of 1 is going to be less than 0, which is less than f of 0, okay? F of 0 is positive, so it's greater than 0. That's why we put it on this side, okay? So then you can now say, by IVT, you can now, by intermediate value theorem, you can now say, there is a point x equal to c, okay? There is at least one point, say there is at least one point, which is the point x equal to c, okay? Between x equal to 0 and x equal to 1, okay? There is at least one solution. You can say, oh, 1 point between x equal to 0 and x equal to 1, such that there is a point which is called point C, or x equal to c, and it's between x0 and x1, such that f of c is equal to 0, which, in other words, which gives us a solution, okay? A solution. Because for us to get a solution, it must give us an answer of 0 when we substitute it into f. So there is a point which will give us an answer of 0, okay? Or there is a solution, okay? In other words, you can put in bracket to say, there is a solution. There is a solution. A point which gives us a 0. That is it now. Now, this is exactly what we needed to do for this question. Let's go to part B and let's just keep using this IVT. This is where you must be good at this sentence at the end, and then you'll be good. All right? Goodbye for now.